everyone. You're watching this because you just went through your note sheet and you took a look at these examples and you tried them on your own. And so now I'm going to take you through them so you can correct your answers, or if you weren't able to figure out any of them, then you can use this as a key and kind of guide you through filling out your notes. Okay, so we're going to take a look at the first problem here where we're actually applying the Pythagorean theorem, and these are the types of questions that you're going to see on the MCA test. So here's example number 1. So we have a square here, and we're trying to find the distance of AD. So we want to know this length right here. So what is that length? Well, if we take a look at this, if I break this into two triangles, there I've got my right angle. And if this is a square, all the sides are the same length. So if this is square root of 52, this is also square root of 52. And what I'm trying to find is my hypotenuse, which is C. So here I can say A and B are both square root of 52. Now if I use the Pythagorean theorem, it says that I can take A and square it, add it to B and square it, and that equals C squared. So now if I try and solve for C, if I type in the square root of 52 in my calculator and hit square, it's going to actually undo itself. And so type in square root of 52, hit to the second power, and you will see that the answer is 52. Because squaring a number is the opposite of finding the square root. You get back to the original number. So same thing here. If I take this number and square it, I get 52. So here I've got 52 plus 52, which is 104. And that equals C squared. And clearly this isn't 104 units here. So I've got to take the square root of 104. If I type that in my calculator, square root of 104, I get about 10.2, and that equals C. So this right here would be about 10.2 units long, and if I type in the square root of 52, this is about 7.2 by 7.2, and that makes sense that this would be a little bit longer. All right, let's look at the second example. So here we've got some roads, and here we've got Birch Street and Asher Street and Alder. And if you notice, Asher and Alder Street make a 90-degree angle, and this forms a right triangle. How many more miles would you travel if you rode your bike down Ash and Alder Street? So instead of taking the shortcut down Birch, what if I take Ash and then Alder Street? How many more miles am I going to end up traveling than if I would have just took the shortcut down Birch? Well, in order to figure this out, I have to know how long Alder Street is. So I can use the Pythagorean theorem. Across the 90-degree angle is the hypotenuse, which is C. And this could be A or B. Well, we'll just call it B, and here's A. Let's figure out how long Alder Street is. So applying the Pythagorean theorem, A squared plus B, which is Ash Street, 8 squared equals Birch Street, 17 squared. So now I'm going to evaluate here. I have A squared plus 8 to the second power, 17 squared, 289. So now I have my equation here. Take away 64. A squared is equal to 225, and of course I need the square root. Your calculator probably said 15 as well. So this right here is 15 miles. So now let's figure out the distance. If I took Ash and Alder Street, I would be traveling 15 plus 8. And that's 23 miles. Now if I took Birch Street, I'd only have to go 17 miles. So they're asking me how much more miles, or how many more miles would I have to travel? Well, what's the difference between 17 and 23? If I subtract 17, I get 6 miles. So how many more miles would I travel by taking Ash and then Alder? You travel 6 more miles than if you took the shortcut and took Birch Street. All right, here's number 3. Here we have a parallelogram, and if I am asked to find the area of a parallelogram, I first have to remember how to find area of a parallelogram. Well, if you can imagine here, if I took off this piece right here, and I slid it over and moved it here. So imagine taking this piece off and putting it right here. Do you see how I have a rectangle? Well, to find the area of a rectangle, I take the base times the height. To find the area of a parallelogram is the same thing. I want to take the base and multiply it by the height. So to find the area, base times height. Well, unfortunately here, I don't know what the height of this parallelogram is. I do know that the base is 45. If this length is 45, down here is also 45. But I need to know the height. So using this triangle right here, because it's a right triangle, I can figure out the height here by using the Pythagorean theorem. Well, C is your diagonal hypotenuse, so 41 is the C. 9 is going to be A or B, we'll call it B, and then we got to solve for A. So let's use the Pythagorean theorem. I have A squared plus B, which is 9 squared, equals 41 squared. So let's evaluate. A squared plus 9 times 9 is 81. 41 times 41, 1681. Okay, subtract 81. Well, 1681 minus 81 is 1600. Now again, of course, it's not 1600 units or feet long, so I have to find the square root. 40. So A is equal to 40. So it looks like we have a parallelogram that has a base of 45, because this is also 45. So my base is 45 and my height is 40. So if I take base times height, I would take 40, which is my height, and multiply it by 45, which is my base. And 40 times 45, 1,800 feet squared would be the area. Okay, number 4. Find the area of the blue square. We can see here, this is my blue square, it's the large one. Well, in order to find the area of a square, I have to multiply the side length by this side length. I can say base times height or length times width, but I know that they're the same length because it's a square. So I need to know the length right here. What is that? Well, do you see the purple square here? Has a height of square root of 36. Well, if it's a square, the length down here would be the square root of 36 as well. And if I look here, this creates a right triangle. So to find the length here, this would be my C, my hypotenuse, I could use Pythagorean theorem. So let's try that real quick. Here's my A, and down here is the B. So I've got square root of 36 squared, A squared, plus B squared equals C squared. Well, I just remember from the last problem, when I take the square root of 36, that's 6, and 6 to the second power is back to 36. So, same thing here. The square root of 36 is 6, and 6 to the second power is 36. So then I can add those two up. 72 is equal to C squared. And of course that doesn't make sense. I still have to find the square root of 72. So square root of 72 is 8.48, maybe 8.49. So right here I get about 8.49, which makes sense because the square root of 36 is 6, and this is also 6. 6 by 6. So I've got that now. Now I'm still not done answering my question. The area of the blue square. Well, if this length is 8.49, then this length right here is also 8.49. And to find the area of a square, I take the length times the width, or base times the height. So I would take 8.49 times 8.49 to get the area. Really, what I'm going to type in my calculator is 8.49 to the second power. And I get 72.08, and I'm going to go units squared as the area because I don't know exactly what the units are. So there's my final answer on that one. All right, number 5. Ask me here with this parallelogram to find the length of n. Well, the length of n is this diagonal side. Well, I have to figure out how am I going to do this here. I can use the Pythagorean theorem because I notice that right here is a triangle, and there's the right angle. And n would be the diagonal side, which is actually the c, or hypotenuse. But I can tell here that this length is 14.5. It's just a matter of what this length is here. Well, if you notice on this picture, the distance from here to here is 13. So if I slide my arms up, the distance from here to here is also 13. So from here all the way to here, that is 13. Well, if all the way across here is 17.25, and this is 13, how much would be left for this? So what I'm doing is I'm taking 17.25 and I'm going to subtract 13. When I do that, I get 4.25. So this distance is 4.25. So I'm going to pull that triangle out here. 4.25, and I got 14.5, and then this right here is my C, which is what I'm trying to find. So let's use the Pythagorean theorem. These are my A and my B that make my L, make my right angle. So I have 4.25, A squared plus B squared equals C squared. Now let's evaluate. Definitely going to need my calculator on this one. 4.25 squared, I get 18.0625. I'm not going to round anything right now. 14.5 squared is 210.25 equals C squared. I still can evaluate these two by adding them together. So I'm going to add, and I get a total of 228.3125. Still not rounding anything yet. Equals C squared. Well, I know I need to take the square root of this. So I'm typing in square root, and I get about 15.1 equals C. So it says find the length of n. I know that n needs to be my longest side because it's the hypotenuse, and I'm getting about 15.1, which makes sense. Okay, last example. This one is asking us which point is square root 113 units away from our given point, -7, 8. Well, there's two ways of doing this. One, I could use the Pythagorean theorem, or I could use the distance formula. Let's take a look at using the Pythagorean theorem. Let's just try point B and see if point B is square root of 113 units away. To give you an idea what that means, I'm just going to type in square root of 113, and that's about 10.6. So really what we're trying to find is the number that's about 10.6 units away from our given point. So let's try B. I am going to connect our given point with B, and then I'm just going to create a triangle, just like this. And if I look here, I see that I have a right triangle that happens to be 2 units high and 1, 2, 3, 4, 5, 6, 7 units long. And I'm trying to find the distance here between this point and this point, so that would be my C, my hypotenuse. So let's try this. A squared plus B squared equals C squared. Evaluate. 4 plus 49 equals C squared. And if I add these two together, I get 53 is equal to C squared. And of course, I have to find the square root. So C is equal to the square root of 53. Well, I don't want the square root of 53 as my distance. I want the point that is square root of 113 units away from my given point. So B definitely isn't going to work. B is too short of a distance. So let's try A. All right, let's try point A. It seems like point A is a little bit longer of a distance. Let's use the distance formula for this. So I know this point's negative 7, 8. I'm going to look at point A, and if I start at my origin, I don't go right or left, but I go straight up 15 units. So this would be at 0, 15 as a point. So using my distance formula, I want the distance between these 2 points. Okay, so I want to subtract my x's. And it looks like my x here is negative 7 and 0. So negative 7 minus 0 squared. And then I'm going to add that to the difference of my y. And looks like here I have an 8 and a 15. So 8 minus 15 squared. So let's work this out here. Negative 7 minus 0 is negative 7 squared. And 8 minus 15 is negative 7 squared. Negative 7 times negative 7 is 49. And negative 7 times negative 7 is 49. And the distance is equal to the square root of 49 plus 49. Well, that's 98. So the distance is equal to the square root of 98. Well, wait a minute. This is the square root of 98 units away. I don't want that. I want the square root of 113. So I need a point that is further away. Well, C can't possibly be it, because that's closer. So I'm going to go with D. Let's try D. All right, D. Connecting here, drawing a triangle. There we go. And looks like 1, 2, 3, 4, 5, 6, 7 units away. And here 1, 2, 3, 4, 5, 6, 7, 8 units here. And I'm trying to find this distance, which is the hypotenuse, and we'll call it C. So let's apply the Pythagorean theorem. A squared plus B squared equals C squared. 7 squared is 49. 8 squared is 64 equals C squared. Now if I add these two together, I get 113 is equal to C squared. And to find C, I want to take the square root. So C is equal to the square root of 113, and I've found it. The distance between these 2 points is square root of 113 units. That, my friends, is the Pythagorean theorem in action.